So now we move on to collisions, problem solving in collisions. Question 1, I give you a 2 kg ball, move to the right with velocity 4 meter per second. It collides with another 1 kg ball which is moving in opposite way with a velocity of 0.5 meter per second. After collision, both balls will move at 30 degree and 15 degree from the horizontal. So I need to find the final velocity for ball 1, ball A and also ball B. Okay, so this is a 2D collisions. This is a 2D collision, so whereby it involves x direction and also y direction. For first step, I need to resolve all the velocity into x and y component. So I need to do the resolving for the final velocity, ball A. So I resolve it into the horizontal component. VAX will be VA cos 30, and then the vertical component, VAY will be VA sin 30. Same goes for VB. I need to resolve it into two components. X direction, the horizontal component, VBX will be VB cos 15, and the vertical component is pointing downwards. VBY will be VB sin 15. Okay. Same goes for the initial velocity. This initially both ball is moved along the x direction only. So the 4 meter per second will be the UA component x. The initial velocity for ball A along y-axis will be 0. Same goes for UB. Initially, ball B only have component x. The initial velocity for ball B along y-axis will be 0. So after we resolve all the velocity into its x and y component, then we are going to write the conservation of momentum for x directions. So we consider the x direction first. So the total momentum for x direction before collisions must equal to the total momentum along the x direction after collisions. So how we find for momentum? Momentum is mass multiplied velocity. So the mass for the ball A will be 2 kg and the mass for ball B is 1 kg. So we find for the momentum. So before collisions along the x-axis, ball A are going to have 2 multiplied 4 plus 1 kg for ball B and minus 0.5 for ball component X, initial velocity component X, ball B. Why negative? Because the direction is leftward for ball B. Then after collisions, we are going to have 2 multiplied VA cos 30 plus 1 mass for object ball B multiplied VB cos 15. So we are going to have one equations, but we cannot solve it because VA and VB is unknown. So we put as equation 1. Then we write the conservation of momentum for y directions. Consider the y directions. So total momentum y direction before collisions equal to total momentum along y direction after collisions. So before collisions, we doesn't have any component y. So the total momentum will be 0. After collision, we have velocity component y, VA sin 30 and VB sin 15 for ball B. So we have 2 multiplied VA sin 30 plus 1 multiplied negative VB sin 15. Why we have to put in a negative sign? Because the component y for the ball B is pointing downwards. Okay, because this one is downwards, this one is leftwards, so we have to include the sign negative for the directions. Then I obtain a second equation. 0 is VA minus 0.259 VB. So this is my second equations. So I'm going to press the calculator, solve it using the calculator in order to obtain the value of VA and VB. So find for the mode whereby you solve the simultaneous equation with two unknown. So put in my A is 1.732, B is 0.966, and 7.5 is C. Second equation, I have 1, negative 0.259, and 0. Then my first unknown is the value of VA. So my VA is 1.37 meter per second. Second unknown y in the calculator represent VB. So my VB is 5.3 meter per second.